Good morning, good afternoon, good evening, depending on where you are. Thanks for joining the MySQL Live webinar today. My name is Heyman Matthew, MySQL Cloud Account Manager. Before we start today's webinar, I'd like to introduce our speakers. First up, Raz Choudhury, CEO of Sam.ai, and second, John Kehoe, MySQL Principal Solution Engineer. We're going to present on how Sam.ai was able to double their speed performance using MySQL database service with high availability in Oracle Cloud. So if you have any questions during the webinar, please feel free to drop them in the QA box. Our speakers and Dale Dasker, MySQL Solution Engineering Manager, is available to answer your questions, whether during the presentation or at the end of the presentation. Lastly, we will send the webinar recording and PDF of the slide deck to every webinar attendee within a few days. So without further ado, and once you're ready, Raz, John, I'm handing this over to you guys.
Very good. Thank you.
Yeah, thank you, Hemant. Hi, everyone. Happy to be here. My name is Raz Choudhury. I'm the founder and CEO of Sam.ai. We are a software company based out of New York City. And essentially, we leverage conversational AI to build conversational intelligence. We started out in 2016, and over the years, we've learned a lot and finally delivered on the promise of a five-hour work week. Yeah, I am happy to show you what we've built and also share some insights. John, go right ahead.
Hi, I'm John Kehoe. I'm a principal solution engineer here with Oracle. I've been here for about 12 years, working in the MySQL group. We met Raz about March of last year and started the entire process of moving him over from AWS to Oracle Cloud Infrastructure, and it has been a successful run. We've done some pretty neat things you weren't able to do before, Raz, so we're so happy we've been able to help.
Awesome. So let me share with you, folks, what we're going to cover today. So we'll essentially start things off with what conversational AI really is, and more importantly, what is conversational intelligence and its relevance. We'll then get into the need for speed and why you really need to have a super fast engine to run conversational intelligence. We'll then get into a historical look at our journey from a basement server in Woodside, Queens, New York, to a co-location server, to a pretty good hosting provider, and now to a great cloud provider. So, you know, I don't know if I've shared with you this, but we started out, my CTO and I, at a different company. I founded and ran that company. It's called USA Web. And essentially, it was a long journey for us in terms of figuring out what is the best provider for our software. So I'll share some of that with you. We'll also take a snapshot of what the conversational AI engine at Sam.ai does today via a live demo. And then John is going to get into HeatWave, AutoML, and Data Lakehouse. And then throughout, we will answer any questions you have. And also, I think Dale will also quarterback some of the questions that might come up towards the end. Okay, so conversational intelligence refers to the ability of a system to engage in an intelligent and natural conversation with humans. It involves understanding the context and intent of the conversation, therefore generating appropriate responses and adapting to the needs and preferences of the end user. It's pretty different from a chatbot. Chatbots are essentially designed to provide information based on certain conditions and rules with defined tasks. Usually, chatbots cannot give you reports or cannot give you dynamic data that is specific to the questions that you're asking for. However, there are some parallels between chatbot and conversational intelligence, and it's sort of a subset of conversational intelligence. So why is conversational intelligence relevant? I think we could all agree that data is a big part of the way we live in this world today. You know, for starters, it's the very data that defines a business. Businesses live or die based on data. I think we could all agree that also it has impacted our personal lives, for the past at least 5 years or so. Everything from how often we exercise could be revealed through viewing data to even, the type of sports that we watch. In fact, I'm a basketball fan. So since the late 90s, I've been watching basketball. And what's amazing is that even how the game of basketball nowadays is played has changed because of data. If you watch basketball way back in the late 90s, you would have noticed that not too many players would know how to shoot three-pointers. And because the tradition of playing basketball was really all about having a certain amount of arrangements in where you sort of position your key players, and everyone had a specific role. When you watch basketball today, it's very, very different. In almost every team, a vast majority of the players that are on the floor could do pretty good three-point shooting. So the game is heavily based on three-pointers now compared to what it was just a couple of decades ago. So it has changed drastically. And some might argue that it's not as fun as it once was, but it has changed. So I think we could all agree that there's a tremendous amount of data, and the data actually defines a lot of what we do on a day-to-day basis. However, getting access to that data hasn't changed much. And what I mean by that is, if you look at how we typically access data, we're usually clicking, tapping, typing to get that data. In fact, it's not just a single click that gets you there. I personally think that the way we access data really hasn't changed much since Windows 95 came out. And that's because you still have to click, tap, type to get that data, right? There's usually a team of people building interfaces and iterating that interface to make sure users have the best experience in interfacing with their data. But that data is still pretty tough to get. And most of us don't realize it because we're so accustomed to logging in, typing, making at least 30, 40 clicks to get to what we need for a single operation, for a single task, right? So it's not ask and you shall receive. It's more like ask and then wait. And then, before you even ask, you should really know how to use the software, and then wait for it to load, and then see your data. And even when you see that data, it's a ton of data presented to you. So for example, search engines, right? When you search something in a search engine, there's literally hundreds of thousands of results, right? It's up to us and our eyes to visually go through them and decide what we want to see. So it's like a huge menu option. It's like you walk into a restaurant and you just want a burger and some fries. But before you could order that, you have to select the number on the menu, but the menu has hundreds, if not thousands of options, right? So getting that data and then deciphering that data is something that is pretty tedious. In my personal opinion, it hinders creativity. It hinders flow of thought. How we make decisions are based on data, yet if you have to make literally 15 to 20 clicks to get to your data and then digest that data, you'd be hesitant, naturally speaking, you'd be hesitant to ask, 5 other questions because you really have to work for that data to show. So our philosophy from day one has been to humanize that software experience. We wouldn't have had the courage to get into AI at such an early stage. We started in 2016 when, AI was at its infancy in terms of, libraries and what was out there. Most providers didn't have AI as a service. I don't think anyone actually had AI as a service at that time. So we were fortunate enough to have been exposed to software development for a while. My CTO and I, we built hundreds of complex web mobile app when we were running USA Web. So what we wanted to do was really build something that would be fundamentally different. And what I mean by that is we didn't want to change much in terms of how we interact with software. We simply wanted to change the way we use software to get data. So the challenge in the beginning really was, well, how, machines are so smart, why can't they just understand us and give us that data? It turns out it's language in general is pretty complex. It takes a human to quite a bit of time to learn a language, and more importantly, machines were just not built to understand human language. Luckily, in the 80s, a lot of mathematical formulas came out of MIT, Stanford, and other places. And in the late 90s and early 2000s, the IT industry built a lot of software, which luckily generated a tremendous amount of data, right? So we had the fundamentals from the 80s in terms of mathematical formulas. In the 90s and 2000s, we had the data, right? And now, in sort of the second decade of this century, we're able to finally say, well, isn't there a better way to kind of decipher that data? Financial services. Prior to starting USA Web, I worked for IBM for about 5 years. I was at Goldman Sachs as an IBM consultant. I was at Equitable Mitsubishi. What I found interesting was that financial services companies were using complex AI models way back. This is 2002, 2003. And they were really using AI, basically some of the predictive analytics stuff way back then. And they were hiring these PhDs that weren't programmers from MIT and other places to really come up with formulas that would help them make predictions for trading purposes, for projections, and things like that. So I had exposure to the fact that there were engines and there were formulas that we could definitely leverage. What I didn't realize was how difficult it was to get our development team to figure out sort of natural language, right? So we use a lot of NLP, we use NLU, we then realized we have to use ML and make it supervised. And then the problem was, well, where do we get all the data? So we had to build a whole bunch of software suites, CRM, email marketing, all these others, which wasn't the main focus, but we had to build these software to generate our own data. And then, train that data, make them labeled, and then even go as far as use aspects of deep learning to make it all work. So conversational intelligence via conversational AI was not a smooth sort of journey for us. We spent the first 2 years making a ton of mistakes. By the way, I'm in Manhattan, and if you hear fire trucks, my windows are closed. There's not much I could do, so I apologize for the background noise. But I'm sure they're out there saving lives, so just excuse the background noise. So conversational AI was an interesting concept in the beginning. It became a super tough challenge, and then it became sort of a fun project for all of us at Sam.ai. What I'll do is I will kind of show you a quick snapshot of what it exactly does. If you're not sure what conversational intelligence does, well, instead of making a lot of clicks and learning a software and then getting that data, you could just ask for that data, right? So for example, if you are in marketing and you wanted to know how many visitors you got on your website in the last 3 months, you could simply say, how many visitors did I get in the last 3 months? Instead of having to log into Google Analytics, go through the menu, go through the options, drill down, select the date range, and then wait for it to load. Considering the fact that considering that you already know how to use Google Analytics, you would then be able to see that data. With Sam.ai, what we essentially did was we took a very simple interface, which is just talk to the system or using your microphone or type. If you are in an office environment and you can't really be loud, you could just type, right? So talk or type, use voice to text, and then ask whatever you want of your data. We don't focus on other stuff like weather and movies and driving directions, but we focus mainly on the data that you have. The data that you have might be sales data, marketing data, data that lives on SAM, data that lives outside of SAM. But the idea was, well, what if we could just ask for that data? can we not train the system to understand what we're asking for, then generate a SQL report live and then spit that out. And after a couple of years of failure, we started making progress, and we then delivered. I think it was towards the end of 2020, finally a product that actually understood a vast majority of what people were asking for. This is a snapshot. I will get into a live demo that will have a little bit more depth, but I wanted to just show you this graphic so you understand what conversational intelligence looks like. Well, what do you get? Like, why would someone even have a conversational intelligence engine? What is the relevance, right? The relevance is that it's about 402% faster than having your team members click, tap, type to get that data. Meaning you're saving not only their time, but you're also saving a tremendous amount of effort that it takes collectively to train people in software, to support them using software, and more importantly, to then have them use or adapt to using that software. So it is a lot faster. And the other thing that we realized that we actually didn't realize when we started working on conversational intelligence is that you're actually able to ask things from your data that you otherwise cannot from a user interface. In many cases, let's say you're using Outlook. There are things that you could ask using SAM that you otherwise can't ask Outlook to get you that data. So conversational intelligence allows for something that we term nuanced reporting, which is very, very specific to a human language, or reporting that's based on data from multiple data sets, right? We call it holistic universal data. So I will show you some live examples of those two things in a demo quickly. So before we get there, I want to share with you our journey in terms of choosing the right provider. And I'll kind of walk you through, all that we've been through in terms of, our selection. First off, as I had mentioned to you, I founded and ran a company called USA Web. And it was a hobby first. I was doing it as a consulting gig while I was at IBM in '99, but in 2003 it became a real thing. So at first, it was me and a couple of other fellow IBMers that started out of my mom's garage in Queens, in Woodside, and this is a tiny picture. You can't really see that well, but that's how we started with hosting. We had a server, a powerful machine, and a powerful PC at that time, essentially, with a dedicated IP address from our, I think it was called Covad, or a provider, ISP provider that was for businesses at that time. We then use IIS to configure a web server and then run it. It was pretty risky, but we had to have, I had to ask my dad and my mom for rewiring the whole house to be a 220 volt house, because we had to have types of redundancy that you typically don't have in a house. Long story short, we did that for about 3-4 years, and then we realized, well, that's just not very reliable. You don't have biometric entrance at your house, and you don't have all sorts of sprinkler system that you're expected to have, and clients were hosting sites with this. So we then decided to partner up with a provider in Manhattan, Gotham Web, and at that time they were doing a lot of co-location stuff. So we co-located our server to a couple of racks at Gotham Web. Gotham Web had another data center in New Jersey, Weehawken, New Jersey. So we had somewhat of a redundancy from Manhattan to WeWork as a failover. And this is, mind you, this is after 9/11. We were cognizant of the fact that downtown, Gotham Web was around 14th Street, which is lower Manhattan, and 9/11 wasn't. The World Trade Center wasn't that far. So we realized Gotham Web was not going to be a long-term partner, because their redundancy of failover was really just New York and New Jersey. We then, in 2010, after about 7 years, we scaled up a lot. We grew as a company. We grew a lot, and we wanted to have sort of nationwide type of redundancy and setup. So we moved our stuff to Rackspace, and at that time, Rackspace was sort of the premier company you go to for robust hosting. And then DigitalOcean came up with something called SSD servers that had SSD hard drive. And one of the clients that we had at that time had a lot of issues with speed. So we figured, okay, let's see if SSD could help solve some of that problem. And at that time, SSD hard drive wasn't a standard on on like servers, right? You would get IDE hard drive. So we went with DigitalOcean, and their support unfortunately wasn't really good. We suffered a lot. There was just delays, and we couldn't really get the proper support. So in 2016, when Rama and I founded Sam.ai, we were swayed by AWS. They were courting a lot of startups, and we were given a huge amount of credit, and it seemed to be very startup friendly at that time. So we said, all right, fine, we'll move out from DigitalOcean and go with AWS. We stayed with AWS for 5 years or so. I think AWS at that time, when we started out, they were really pretty good. But then the problem that we ran into had a lot to do with their two things. There was support as well as how they were pricing things. There's a lot of hidden pricing built into AWS. For example, the specific problem that we had was that we would get these high-end servers for our database, but the IOPS were intentionally limited. So we would have clients asking for reports and then waiting quite a bit of time to get that report. And more importantly, in some cases, some of the reports wouldn't have been generated because our system is coded in a way where if it takes more than 30 seconds, just tell the end user it's not available yet. So we were getting a lot of those conversational requests where there was a sort of a built-in timeout, and a lot of the stuff we wanted to do couldn't do, or were very cost prohibitive at AWS. So the IOPS was a major issue. And the other issue that we ran into towards the end of our journey with AWS was their support. It was pretty good in the beginning, but then towards the end, it was just really horrible. We had to escalate a lot of matters. We couldn't get, we were actually paying for premium support, but we didn't ever feel like we were getting that premium support. We ended up just deciding that it wasn't worth the amount that we're spending and the limitation that it came with, as well as all the support frictions. So in early 2022, we started having conversation with Oracle, and we were kind of hesitant to move in the beginning because we're like, well, we know we're not happy with AWS. We probably just have to spend a ton more money to get it all fixed. But when Oracle came into the picture, it wasn't just their platform. It was the fact that, well, we've been a MySQL house forever. So we're like, wow, we're going to have access to MySQL, guys. That's super awesome. Okay, you're going to give us a quote based on what we're spending now and slash that by 40 to 50%. Okay, that's impressive. That's got my attention. And then more importantly, even in the beginning, we were in conversations with folks like John and others that knew what they were talking about. They weren't, they weren't support folks in general. They were senior architects that actually understood core technologies that were relevant for us. And from day one, we talked about performance being the most important thing. So let me actually take you to the next slide. So the reason we essentially went from a good hosting provider like AWS to a great one had a lot to do with increasing our performance. So right now, our conversational engine is 2 times faster. And what that translates to for us is not just the speed, but also the fact that our engine could actually answer more questions than it was able to answer before. right? And the reason why it's able to answer more questions is because we're not hitting that 30-second limit that we coded in. So the users are getting much more out of our system because we're on OCI. The people are super cool, very, very smart and never cocky. And that's common in tech. You know, you work with smart people, but they're pretty tough to get along with, or they're not friendly enough. But the folks at Oracle have been super cool, super genuine, and very, very dedicated. Not to mention the fact that they are the engineers, some of them from core technologies that we use, such as MySQL. And lastly, the pricing was very, very predictable, right? So we're not constantly surprised every month or every 2 weeks on something that we didn't expect in terms of what our what our costs are. So those are 3 elements that are important. I'm going to now turn this over to John, who will spend some time talking about some of the things that Oracle has in its roadmap and how Sam.ai potentially will be using some of those things. So John, please take it away.
Thanks, Raz. So where I come into the equation was early in March when we started having our conversations. And it really became apparent that Sam.ai was paying a lot for their environment in Amazon. And I remember being brought on to a call where Sam was having an issue with a server over in AWS that had been quite reliable for a number of years. And the solution wasn't a root cause analysis. You know, I'm an engineer. I like to know what the root causes are because I'm going to fix it not only for my customer, but other potential customers. But their solution was double the number of servers you have and put a load balancer on it. And then that way, when the server fails for whatever unexpected reason, you still have an environment. Tend not to think of that as an acceptable solution. So we went through a series of upgrade steps with Sam in terms of their application and making them ready for MySQL 8. And then assisting them with their PHP, their Python components in order to take advantage of it. They went live and been quite happy in terms of predictability in pricing on the Oracle side here with MySQL. Really what you're deciding it on is the number of OCPUs. So think of 2 OCPUs make, or I should say 2 execution threads, or a full core, if you will, is equal to an OCPU. So we were able to go and double the number of OCPUs. We also base it on the amount of RAM that you have, and then we price it based on the amount of data you have. And what was interesting about that is when we were looking at the Amazon comparison, in order to get to the maximum IOPS that we can do, which is 50,000 IOPS, and about a half of 500 megabyte per second transfer, we were talking about a terabyte of storage, and that was $40 a month. Whereas if you wanted to go and get the similar class of performance and technology out of Amazon, it was going to be many thousands of dollars more. And I think that was a really powerful driver for Raz. Migration was also an issue. So we did some hands-on with Sam's people. We have an upgrade checker, if you will, that will go through an existing database and highlight issues that you might have in your migration. So that gave us essentially a punch list to work through in order to do the migration. So very well thought out process and resources. Come the day for the migration, we set aside a day, but the actual data migration went very quickly. So we went from exporting AWS to importing it into OCI. That process took about 2 hours. So that was a cold migration. We could also do a hot migration if we wanted to, which we do with some of our other customers, but the cold migration was a great solution for us. Let me talk a little bit about futures. So these are our products that we have. So one of these is HeatWave. What HeatWave does for us is really it's the first step in creating what is truly a hybrid database. And when I talk about a hybrid database, I mean a database that is well suited to multiple workloads that typically we don't think belong together in a database. So MySQL is great for online transaction processing, but based on the architecture, we couldn't scale it to massive parallel processing like you would see in other Oracle products. Oracle Labs have been working on inventing technology over the years, and I've been involved with HeatWave since 2018, before it was pre-beta. And the decision was made by the corporate architect, Edward Screven, to put HeatWave into MySQL. That was going to be the product that runs HeatWave. It consists of really a network of computational engines, for lack of a better descriptor. So we can scale up to 64 nodes. Each node has 16 OCPUs, so think of those as cores, and half a terabyte of memory. And this is where the coolness comes into play, is that we can take the transactional information and put that into HeatWave on the order of 200 milliseconds. So now you've got the ability to do real-time analytics against transactional data. The data, why is it different? How does HeatWave handle this differently? Well, HeatWave puts the data into a column store. So if you think about the aggregations and the mathematics you might be doing with data, a column store is an excellent way of organizing your data. It's not great for OLTP. So naturally, other people have two separate databases and then ETL process in order to populate really an OLAP database. So you have the expense of the ETL process, software, expertise, and you also have the risk of data exfiltration, because you're now taking it out of one secure environment and then putting it into a processing environment, and then ultimately the OLAP environment. So we eliminated that. And then we did a massive scale up. So the data lives in these computational nodes in memory. You have the MySQL security that you would have with MySQL that you have today, and have the ability to work within one environment. Well, the lab decided, well, what else can we do with all of this horsepower? So again, Oracle Labs was working on an ML project to be incorporated into a database. And once again, the corporate architect said, you know what, I want that to go into MySQL. So it did. So what does this do for us? Well, we're leveraging the data stores that we have, and then this massive ability to parallel process and dedicating that to machine learning. But that really wasn't quite good enough for us. If you think about a classic machine learning workflow, there's a lot of heavy lift associated with it. So you're imputating data gaps, you're standardizing, you're labeling data, you're thinking about the feature extraction. Then you typically have a data scientist who is working with algorithms to try and go and find the right algorithm for the projective analytics that you're trying to get out of it. And then that leaves you with the problem of, okay, how do I code it? How do I implement it? And then how do I accommodate drift? So since we can do that real-time processing of transactional data in HeatWave, We already had our data source because it was already in memory. It was something that was going to be performant since it was multi-processor, multi-node. Again, it could leverage those resources. But that left us with, how do we do it? How do we do it? So the idea came to us that if you've been using SQL the entire time here, why wouldn't you not want to continue using SQL to perform your machine learning? And I know there are some other technologies out there whose claim to fame is using SQL, but it's really SQL as a front end to another machine learning database. So what we did is we distilled this into 6 function calls. So with 6 function calls, you can come up with a representative data sample. You can input data, which is filling in the blanks. You have your feature labeling, feature selection. Then what we decided to do is, okay, let's go and automate the algorithm selection process. So then we go and depending on what you want to do, is take those queries and then break them down into 3 areas. So we have 3 areas of specialization in machine learning today. So the first is your classical classification problem. Then you have your different regression problems, different algorithms you want for that, for doing a continuous wave, if you will, sensor prediction, if you will, of let's say, real estate costs. You have all this real estate data. What would be the expected price for a piece of real estate? And you could go and calculate that based on the different data sets that we have and then the different independent variables. And then finally, most recently, we have added time series. So those are the 3 areas of specialization that our machine learning capability is. And then we've continued to add additional algorithms to this solution. In terms of training, a function call will go and generate a model that we can then go and test against another set of data from that original database source, and then build our inference model. Now, this is where the wheels come off the cart with a lot of AI projects, and that is, how do I go and actually implement the inference model? Typically, it's a lot of coding. Now you've got a lot of technical debt in order to maintain that processing. So again, we said all the data is here. We've got the massive capabilities to go and execute against this data on in a parallel process. We can use it for query acceleration. We can use it for OLAP reporting, and then we can now add the machine learning capabilities. And so in the span of 6 function calls, you can go from your entry point for a typical machine learning workflow, and what we've done is created an automated machine learning workflow. Another part of it that's important for people is the explanation of these models. How did we come to the conclusions that we came to in the inference engine, in the inference model? Why is that key? Well, one of the things we see in the news is people talk about bias of models. So we can go and look at that model and we can see where the independent variables are, and then explain it to you in layman's terms as to what the effect was. And you can see obvious outliers of bias, and you can see if that was something that's valid in your model. You know, sometimes a biased data element has a legitimate use. Say if you're looking at something in healthcare and there are distinct differences in different groups of people, but in finance, you know, we want our financial decisions to be made without visibility into intrinsic characteristics of people. So we can go and make sure that those pieces aren't in our model. We also accommodate data drifts. So we can scale up to 68 nodes for processing. I'm sorry, 64 nodes for processing against 48 terabytes of data. And then we can go and essentially compress that back down to what we would consider day-to-day operational size of HeatWave. It might be 1 cluster node, 2 cluster nodes, 10 cluster nodes. That's all going to be defined by the amount of data that you have. Each cluster node can handle 800 gigabytes of data based on the different compression algorithms we have that can really tokenize and compress that data to a pretty extraordinary level. Where we're going with this now that we have this great engine, we have people who develop models like Sam.ai, and we can go now and incorporate those models through Onyx. So Onyx is an independent protocol for moving models around from one environment to another environment. So although the models are developed elsewhere, you can go and take advantage of those models on HeatWave. So that's a new capability. I'll also go back to other things that we're working on. So there's something we call Lakehouse. It's not currently available, but it is in development. It has been announced, and it gives us the ability to go and take in Parquet files, CSV files, large files that you might have in an object store, and then incorporate them into HeatWave. So we can figure out the data model, data structure, and then bring that data in and then perform the HeatWave magic that we've been discussing earlier. I'll just touch on transparency and pricing. So with HeatWave, there are really two elements to the pricing, and that is the amount of disk storage you have, which is about $40 a terabyte, and then the number of HeatWave nodes that you have. And the HeatWave nodes, and again, this is part of the magic of the solution, is the HeatWave nodes are on the order of $263 per month US. So you could have a HeatWave setup operational for 500 and change, if you will, per month. And if you look at that compared to other solutions out there, they're dramatically more expensive and not necessarily as fast as what we have. That's a presentation for another day, but I did want to give you that thought about what the potential impact might be for your budgets. I'm certainly available to go into deeper dives, and I don't think we want to go into a deeper dive at this point with our audience. But that's how we see helping SAM out in the future. So we've got the performance gains that they've had by moving to OCI, but there's the potential for orders of magnitude further improvements in performance when we start looking at HeatWave, and we're going to be doing our first implementation of that in the coming weeks. So it's an exciting environment, really great people to work with. I have to say, from a techie, I'm really entranced by the solution that Raz and team have put together. So I think that really concludes what I have to say. Raz, I'm going to hand it back to you.
Sure. Yeah, thanks, John. And I think we share the same sentiment. We really haven't ever worked with a provider that's this genuine and is able to offer this level of expertise. The migration is critical, right? And we weren't left in a dark room to figure out migration all on our own. We really had a tremendous amount of support from the OCI team to help with that migration. I know I promised everyone a live demo of the conversational engine, so here it is. So what I'll do is I'll ask Sam a few questions. Now, keep in mind, the actual UI could be very different based on what our clients need, but this is sort of the out-of-the-box solution. And the data that I'm pulling out is actually from multiple sources, so you can see some live use cases. So I'll ask a few questions. What does my sales pipeline look like? So it's a pretty general question. What is my sales pipeline? If I'm a sales guy and I wanted to see what my pipeline is, I don't have to figure out a CRM and go through all the navigation. Irrespective of what CRM I'm using, I have my data right away filtered for me with the graph. And if I want to, drill down, I could click on it and see additional data, right? I could ask something about my, my contacts. How many founders did I meet with in the last 5 years in New York? So what this is going to do is this is going to look at, we use Google Calendar, right? And I have Google Contacts. So Sam is now going to look at my data live in my calendar and my contacts and figure out how many meetings I had in the last 5 years. It turns out I had about 117 meetings with CEOs that are based out of New York. What's interesting about this is that we call this nuanced reporting. If you try to do this on your Outlook or in your Google contacts or calendar, you simply can't get that data because the data lives in multiple different areas. In the case of how we derive that data, we actually mix the data that we get from Google Calendar, then Google Contacts, and then other sources to figure out what their job title is, and then show you that data, because in many cases, your contacts may not have a location of that individual or even the title of that person. And it breaks it down pretty fast. So this type of nuance reporting wasn't possible before. And as far as I'm aware, we're the only conversational AI engine that produces conversational intelligence like this in the market today. I'll ask a few other questions. How many female founders do we know in California? Here's another example. This was actually a request that originated from one of our users. They run an investment firm and they have a portfolio of companies, and they have a new portfolio where they want to focus in on female founders. And they, their interest was, well, how many portfolio companies do we have that are run by female founders? And you can't get this type of information from like a standard CRM or contact management because defining gender or finding out who's in California, all of that data usually doesn't sit in one database. It's usually in multiple databases. So what I was saying earlier was that not only are we using NLP and NLU, we actually have to go beyond that to get into deep learning, get into supervised ML to get this type of report. I'll show you another example. This is from we partnered up about 1.5 years ago. We partnered up with a company called Phone.com. They are sort of the go-to phone company for a lot of small businesses. They have over 30,000 businesses that use them. And one of the problems that they had was that their business folks were just tired of their reporting engine because it just didn't give them what they were looking for. And it was too cumbersome to use. So we integrated with them, and I'll show you the result. How many inbound calls did we get in the last 5 years? So if you're head of sales or head of marketing and you wanted to know how many inbound calls you got, I'm giving you this generic report, but the idea is you could do drill down and filters pretty easily just by asking for that data. 28 inbound calls in the last 5 years that we got. And here are all the details. I'll show you something else. How many referrals did we get from Martin Babinak in the last 5 years? The reason I asked last 5 years is because then I could show you a lot more data. I might have gotten one referral in the last year. So one of the challenges we had was really understanding the sort of variations within within a typical question. So what I mean by that is when a user is asking questions, that question might have things that machines don't easily understand, such as a job title, such as gender, such as a person's name or a company's name. So that took us a while to figure out. And within NLP, there's a framework known as NLTK, and that was sort of the holy grail for us. We really got into NLTK to get a lot of this trained and labeled and figured out. I will show you one other thing. Who in my network knows someone at Goldman Sachs? So this is an example of something we called holistic, unified holistic data. Unified holistic data, the philosophy is very simple. I want to make a decision, but the decision is based on data that might live on multiple databases. So my question to Sam was, well, who can I get introduced to at Goldman Sachs through someone that I already know? So Sam has an engine where it figures out who knows who within your inner circle and who is most likely to give you an intro based on their relationship strength. This is a classic example of unified holistic data. It's a term that we've coined based out of the needs that our clients had. So unifying data from multiple sources is very relevant to decision makers. What we're getting into now are things that are, in our opinion, much more time sensitive and critical. So we're rolling out solutions for healthcare industries where every second counts. If a doctor has to scroll through menus and make a lot of clicks to, just simply to pull up last report of a certain exam, we feel that, just being able to ask that would simplify that whole workflow and give him or her that information that they are looking for readily. So nuanced data, curated data, data that is unifying information from multiple sources is what we were able to achieve over the years, and something that took us quite a bit of time to figure out. One of the things that I often get asked about is, you'll have business folks that'll say, well, can I just not ask Alexa this? The short answer is no, because Alexa is a different type of an AI that focuses on different elements. Our focus, Sam's main focus, is data that's relevant to an enterprise that deals with, management, sales, marketing, as well as data that's critical to clients. So our vision is simply, irrespective of what apps you use and what your tech stack looks like, if you want to unify that data and make that data much more readily available to your end users, Sam could be that solution that unifies all of that and makes it much easier to get to that data. Accuracy is something we take very, very seriously. So we've fine-tuned that. We also show you all the variables that are in that data so that, you could do, drilling down and do some additional analysis from that data alone. I wanted this demo to be about a 5-minute demo. I think I've already reached that time. So I'm going to pause for a second and hand it over to Dale to see if you guys have any questions.
Sorry. Go ahead.
Oh, go ahead, Dale.
No, I haven't seen any questions in the Q&A yet. Thank you.
All right. I did have a question that was sent to me directly in chat, and really it's a two-part question. So who is the target audience, if you will, for HeatWave machine learning? So one area, and again, it pulls back to auto ML, if you will. We're looking at being able to give businesses the capability to go and use machine learning so they can go and find these patterns in data without having to bring a data scientist in. So that's one area. The other area we have a focus on is with those data scientists, providing a tool that gives them the opportunity to do much faster discovery. So in one case, we're bringing the barrier to entry to machine learning to a much lower level, so down to a business level, as opposed to a very larger, more complicated IT type of solution. And then the second question that I had is, what do you see in terms of implementation of machine learning in terms of the impact of auto ML and our approach to machine learning? And what I've been finding in my conversations with companies is there's either initially no interest in machine learning because the barrier to entry for them is viewed as being very, very high, or there are so many other moving pieces that have to be implemented that the event horizon for machine learning is out at, say, the 5-year mark. What we've been finding is with those folks who who dismissed machine learning out of complexity, we're seeing projects being pulled forward to a 12-month time frame from that 5-year event horizon. So that's part of the impact. And then I had a third question, which is, okay, John, this is all beautiful, wonderful stuff. If I'm coming from another cloud vendor, obviously it's a la carte. I'm paying for all of these pieces. You've got your basic HeatWave, you've got your ML now, your auto ML. So how much more is auto ML? And the point we want to make is that's incorporated into HeatWave. So you might just be using HeatWave for query acceleration or reporting, but then you also have access to the machine learning. So again, it's another step in making MySQL a greater hybrid database solution than people normally would think of with MySQL. That's it for questions in my queue.
Cool.
So I think we're probably at a point here to wind things down. Raz, you have final thoughts to share?
Yeah, I mean, I think this was a long journey, but I think we're at a point where we have already gotten our ROI from that switch to Oracle. So we're already pretty much reaping the benefit right away. We thought it would be, a couple of years, maybe the first 12 months is when we're going to sort of get our ROI on that switch. So yeah, appreciate all the support and appreciate all the folks that are on the webinar today.
Very good. I think we're ready to wrap up. Tina, can you close us out?
Yeah, so I can jump in on that. So yeah, Raz, John, thank you both for the presentation. Thanks also, Dale, for keeping an eye on the QA. So since we don't have any more questions that are coming up there, we're going to wrap up the session. So thank you, everyone, again, for joining today. Again, the recording and the PDF of the presentation will be shared with everyone in a few days. And thank you all for your participation. We look forward to meeting you again in our future webinars. Have a great day.